new certain rules that you're gonna have to apply. Always when you're dealing with questions. So let me say this. Yeah. So I have this document. Let me call it. I'm just gonna save it like this so that I can be able to access it. Then I'm going to pin on top. So this is a continuation of improper integrals. I think we had, let me check it. I think it's somewhere here. Integrals. I think it's not categorized, right? Not categorized. To SMT. Yeah. So we have the improper integrals that we did last time. So they're all here. So today's date is, let me check. It's the 11th, right? So I'm gonna write here 11. I'm gonna write 11 here. I'm gonna write 11 March 2025. Yes. So now I want us to proceed from where we left off before we can enter the comparison test, because there are certain questions that I want us to do, which are, I think they're on this part. So I'm just gonna say this. I think I wrote them down here. The first one is this one. It's the first one is the integral from 1 to 2 dx over x minus 1 to the 1 over 3. So I think this one, it matches that one which was asked in the group, right? To how can I do this ones, or integrate it, or solve it without, or evaluate it without having to change the intervals, right? So we can do that. Now remember, I said that the first step that you need to take before solving this is not integrating or use substitution or anything. You just have to first plug these values and check which one can I replace. This is some things are like 3 marks. Which one can I replace? It's just that you might not get a mark for that, but it's just a one step ahead, right? Or one step to getting the correct answer. So if I plug 2 here, I'll get a 1 in the denominator, which does not give us undefined. If I plug 1 here, I get that this is undefined. So it means that this tells me that I need to replace. So let me replace this by A. Always every time I replace this one, I'll write A. If I replace this one, I'll write B. Then 1, right, to the plus, because it's A. It's our lower limit, so that one will be plus. So I write A here, I write 2. Then I write the x over x minus 1 to the 1 over 3. We agree right now? Yes.
Can you please use a white background when you're using back? Some of us have eye problems and you cannot enter.
I wanted to continue from this PDF. What can we do? I wanted to continue from this PDF so that I don't have to issue when I'm taking screenshots. So I don't have to combine these notes. So I don't know. I should use a white background. Okay, let me try to open a new one. Now let's say that it's 11, right? Say that it's 11 March. Oh, these things are too big. Say that it's 11 March. And these are improper integrals. So I'll say that the first question that we're given is we have the integral from 1 to 2 of dx over x minus 1 to the 1 over 3, right? Then I said that the first thing that we need to consider is what is subbing this and this. Check which one gives us undefined. So this is the first step, right? I try to combine questions that we're going to have to use different approaches so that you can know when they bring a different question, you can be able to answer it. So I said that if I plug 1, I'll get undefined, right? If I plug 2, I won't get undefined. So it means that this tells me I'm supposed to replace 1. And I say that I'm going to replace it using A. Every time I replace the lower one, I'll use A. Every time I replace the upper one, I'll use B. So I'll have A here, 2, 1 over x minus 1 to the 1 over 3 dx. So now I'm done with replacing, right? Then now I check, what else do I need to do next? That is the question that I can ask myself. Or I can start by doing this. You can say right, and then from here I can let u be equals to x minus 1. Then I derive this, I'll get to the x. I think the question I was asked was to do this, or the request that I was given is to do this without changing the intervals, right? And then this will be of the integral, or not the integral, have the limit. We'll have the limit as a approaches 1 from the positive of a2 u to the minus 1 over 3 du. You see, right? And then for me to integrate this, I'm going to do this. I'm going to say u to the minus 1 over 3 plus 1 over minus 1 over 3 plus 1. Then I put my a and 2 there. Then this would be the limit then this would be u 2 over 3 over 2 over 3 a2, right? And then that over 2 over 3, I can just take it out as 3 over 2 as a approaches 1 from the positive of u to the 2 over 3 a2. Then before I can plug back this, don't forget that I didn't change the intervals. I need to come back and plug my u, right? I'll have the limit as a approaches 1 to the positive. Then our u is what? Is x minus 1, right? X minus 1. 2 over 3. A2. Then now I can plug those. The limit, guys, you plug it at the end after you're done with expanding your thing. Your function. 2 over 3, right? Then it means that from here we're going to have, yes, we're going to have this, which a approaches 1 to the positive. So now we're going to have what here? We're going to have, this will be 1 minus, this will be 1 minus a minus 1 to 2 over 3. Do you agree here? Then if I come back and plug my limit, I'll have 1 minus 1 to the 2 over 3. And then this would be 3 over 2, 1 minus 0, which is 3 over 2. So we get this. Is there anyone with a question? Is there anyone with a question? So here's okay, before you ask, here's what they can say, right? We can give you this. Oh, yeah, please ask.
And ask if we do the integral first and then do the limit after.
Yeah, we're gonna have a problem. That's why.
It would be wrong.
Yeah, it would be wrong. It would no longer be improper. This is why we're calling improper. We are saying it's almost impossible, or it is impossible for us to do this without having to. Without it would be. We are saying that it's almost, or it's impossible to integrate or to get to the correct solution without changing the limit.
Okay.
Yeah. So we get this right now. Do you agree? Yes. All right. Okay. Let me. So it means that I can continue, right? So I was saying here that they can ask you a question, right? And they say, determine whether the integral converges. Right? Then they say, if so, find its value. I specified this last time. Find its value. The value of the integral is 3 over 2. So we know we can say, therefore, the integral converges and its value is 3 over 2. We say right now, yes, the integral converges and the value is that. Do you agree? So let me check the other question that we have. Oh, I wrote it, I named it immediately, right? It's this one. The question that we have second is this one, the integral from -1 to 1 of dx over x squared, which is also 4 marks, right? Then we can compute that. So number 2 is the integral from -1 to 1 of dx over x squared. Now here's the integral. Now again, we are used to saying if the integral, if you plug maybe one unit and then you get undefined, and then you can replace that unit, right, or that value. So in this case, if we plug -1, we won't get undefined. You agree, right now? If I plug -1 on x, I won't get undefined. If I plug 1, I won't get undefined. So someone would say, man, let's just integrate straight, you see. And then we come, if we integrate straight, we're going to get to this. We have -1, 1. And then we have x to the -2 dx. And then we would have x -2 plus 1 over -2 plus 1. Then we have -1, 1. And this would be x -1 over -1 plus 1, 1. And this would be, it would have -1 over x minus 1, 1. Then we would have -1 over 1 plus 1 over -1. Then this would be -1, it's -2. You see, right now, you would be correct. You agree, right now? If you do this, you'll be correct. But don't forget, these are called improper integrals. They're gonna give you 0. You see, ne? I was answering the previous question which I was asked, would I be wrong if I do this? No, you won't be, but you are doing it in a wrong concept. You would be wrong in this concept. So you're gonna be marked wrong. So be careful. So we know the answer is -2. Yes. The question is, how can we get there using improper integrals? Now we have 1 minus 1. So for us to do this, we need to find the number in between -1 and 1. And that number is -1. That number is C, which is -1 plus 1 over 2, which is what? 0. You see, right? That means that this would be from -1 to 0 of dx over x squared plus from 0 to 1 of dx over x squared. And then we can be able to replace this 0, because it gives us undefined, right? So here I'm going to choose B, choose 0 from the left. We agree here, right now? And then of -1 B have dx over x squared plus the limit as A approaches 0 from the right. And then we say dx over x squared. A 1. Then here, let's have this. I would have this. You see, I chose different variables, right? So I would have to integrate this individual. So let's.
Can I please ask?
Yes.
When we pick a value to replace, we must always pick the one that's going to give us indeterminate, like 1 over 0 or.
Yes. That's the case.
Oh, okay.
Yeah.
Okay. Thank you.
So now we have this, right? So I would integrate this, but let me first start by rewriting it first, because already we know the integral. So let me write it in this manner: plus the limit as A approaches 0, the positive of A1 x minus 2 dx. And then this would be the limit as B approaches 0 from the left. Then this would be x minus 2 plus 1 over minus 2 plus 1 minus 1b plus the limit as a approaches 0 from the positive of x minus 2 plus 1 over minus 2 plus 1. Then I have a and 1. And then from here I'll have the limit as b approaches 0 from the left. Then I'll have x minus 1 over minus 1 minus 1b plus the limit as a approaches 0, and then of x minus 1 over minus 1 a1. Then here we'll get this, the limit as b approaches 0 from the left of minus 1 over x minus 1b plus the limit as a approaches 0 from the positive of minus 1 over x a1. Then now I can apply those rules. The limit as b approaches 0 from the positive of, we have minus 1 over b, this is gonna be minus is plus 1 over minus 1 plus, then this would be the limit as a approaches 0 from the positive of minus 1 over 1 plus 1 over a. Then this would give us this, the limit as b approaches 0 to positive would get minus 1 over b minus 1 plus the limit as a approaches 0 to positive minus 1 plus 1 over a. Yes.
How is it limit as b approaches 0 to the positive now? How did that change?
Oh, I changed it to the positive ish. I didn't say this. Let me try to fix this. Oh yeah, ish. Yeah, so let's check. We exchanged that with 0, and then we did this. We said x minus 2, 0a. Musia didn't make any mistakes right now.
No, you didn't.
Minus 1. This is minus, so I can subtract this. Then if I subtract this, I'm gonna say this. Yeah, it's correct. So this would be, if I apply the limit here, I'm gonna get what here? If I apply b on this side, I'm gonna get what? Minus infinity right now. Minus 1 plus, if I apply here, minus 1 plus infinity. We agree right now? And this would be minus infinity plus infinity. We'd get something like this. We agree right now? Do you agree?
Yes.
Yes. So remember, check. If you did it for the first time, you did it using the normal integration, you would find that this thing, it converges. You agree right there? You'd find out that it converges. But let me try to scan this question and see what we get. Yeah. If I scan it, I find that the integral diverges. So imagine if you had done it in that way. Actually, let me even do this. Oh, I see here. I think we're also allowed to take it as 1. We can even, I think here they took it like this. I think it would be best if we take this as one function. Instead of taking this one as B, we take it as both as A. So this will be fine. We'll take this as AA, but in most cases they don't make any changes, or it will only be a problem if we're dealing with a log. I think if we reduce this, it's gonna help us to summarize work, so that we don't have to know a lot of things. So even this is A. It means that wherever there's B, you're just gonna write A. A. You see, right? So even if we do this, we're still going to get the same thing. We're still gonna get that this thing diverges. So let me just, wherever there was B, I'm gonna write A. Yeah, I'm just gonna write A. Yeah, that's fine. You see, right? So we get this, and what we know is that this will diverge. So this will diverge. No, okay, yeah, okay. There's this, right? The limit. Yeah, I think we need to know this. Here I didn't apply this property. I think it works also here. There's this, guys. The limit as x approaches 0 from the left of 1 over x, and also the limit as x approaches 0 from the right of 1 over x. They might give you marks based on this. What is gonna be the answer here? The answers can be the same. They can't be the same. What will be the answer on the left hand side here? Minus infinity, because we are approaching from the negative. You see, right? Then this one will be positive infinity. So this one we can plug minus infinity times negative to be positive infinity. So this will be positive. Yeah, if we apply these properties, we'll be fine. Let me just underline them here. I won't erase them, so that when I send you these notes, you can know what's happening. Yeah, so yeah, I just unplugged this, right? I want to change the pen a bit. I think it's low, so I'll plug it back. So let me send this thing in the group so that you can see what I was talking about. I'm gonna send the two of them. So I also took some questions from the tutorial that we can do. So let's go check the second question. Well, I only took 2 here. So I showed you this first one and the second one. So we come to tutorial 4, right? We have some questions here from tutorial 4. A, B, C, D, E, F. So I'm gonna do a few because some are similar, right? I'm gonna do a few. So we'll do the rest. Which ones? Can you tell me which ones should I do? Just choose 2 between A to D. I'm only gonna do 2. Anyone? You can send in the WhatsApp group if you don't wanna type here. I'm actually there now. You can send in the WhatsApp group. Between A to D, which ones should I do? 2 questions. First come, first serve. And then I'm gonna write 2 so that AC, right? No, choose 1. I want one person to choose 1, then the other one chooses 1. Choose one thing, then the others can choose it. A. Then the other one can send again. Then we see it's A and what? E. All right. No. I said between A and D. E I'm gonna do it, and F I'm gonna do it. Okay, I'm gonna do A and C, right? Between A and D. A, B, between A to D, right? So I'm gonna do AC, it's fine. So after that, E I'm gonna do it, F I'm gonna do it. So A is when K is greater or equals to 1, right? K is greater or equals to 1.
Yeah, I give my EF.
K is greater or equals to 1. K is greater.
Yeah, what's that?
Yeah, let's unmute. Let's mute those mics because you'll find yourself saying things here. What?
Listen to this step, man.
Ninya kaifi? E. I said I'm gonna do E. It's greater or equals to what? 1? Yeah, so we have A here, right? Now we want to find the integral of this. If we plug 0 there on X, we're going to get undefined. So already I know which one to change, right? So I'm gonna have the limit as, let me change this pen. I'm going to have the limit as, I'm gonna use A, as A approaches 0 from the positive of A1 x to the minus k dx. So first I can start by integrating, then I'll consider the conditions later. There are many ways you can do this. So let me start by integrating, then I'll consider conditions later. So this is going to be the integral. So let's not forget to put equal sign. As A approaches 0 from the positive, if I integrate this, I'm going to get x minus k plus 1 over minus k plus 1. A to the 1, A1. Then this is equal to the limit as A approaches 0 from positive. Don't have if I plug 1 there, I'll have 1 minus k plus 1 all over minus k plus 1 minus A to the minus k plus 1 over minus k plus 1. Right, now the denominator is the same, so I can just simplify this like this. I can just say 1 minus A to the minus k plus 1 over minus k plus 1. So now I've integrated to this part, right? I've simplified this. So I want to consider this. And this will occur, don't forget, this will only occur such that k is not equal to 1. You see this integral, because if k is equal to 1, this will be undefined. Automatically, this integral diverges from the beginning when k is equal to 1. You see? So I'm going to come and say for k greater than 1, right? So for k greater than 1, or I can say for k equals to 1, let me start with k equals to 1 because I had that say I want these conditions, all of them. For k equals to 1, I must check what will minus k plus 1 be. This one will be equal to what? 0. We agree right now? Since this will be equal to 0, now don't forget this here. I forgot to say this. We must check how many variables we are presented with. We are presented with k and a. First I start by checking k. After I check a. So we say that a is approaching what? As a approaches 0 from the positive. Now what will a to the minus k plus 1 approach? Right? This will be 0 to the exponent 0. Do you agree with me? Because this will be 0 and this will be 0. So 0 to the exponent 0 will be what? Infinite. We agree, right? So this will approach infinite. Because k minus k plus 1 is 0. Already we know. So since that is infinity, now this simply means that we are going to have 1 minus infinity over minus k plus 1, which this will be infinity, your minus infinity over minus k plus 1, which will be minus infinity. Do you agree here? It can be minus infinity or positive infinity. Doesn't matter as long as it's going to diverge. Someone could decide and say this is minus infinity, then they factor out negative and say k minus 1. Then they say this would be infinity over k minus 1, and it's infinity. You see, right? So when k is equal to 1, this thing diverges. So we can say, therefore, the limit, I'm not gonna say, whoever that has their mic on, please, let's turn it off. So we're going to say the limit, I'm not gonna say the integral, the limit x to the minus k diverges when k is equal to 1. You see, right? Then I come and check the second case. Don't forget case 1, it was that k is equal to 1. So I'm gonna put a star here for case 1. Then I'll put 2 star for case 2. Alright. So I'm going to say for k greater than 1, what will minus k plus 1 be? If k is greater than 1, let's say k is 2. Minus 2 plus 1 will always give us negative. Minus 3 plus 1 will always give us negative. Minus 4 plus 1 will always give us negative. You see, right? So this simply tells us that this k plus 1, minus k plus 1 will always be negative if k is greater than 1. You see, this will always be less than 0. So now we're done checking k. Now we check a. We say as a approaches 0 from the positive, then what will a to the minus k plus 1 approach? Now we must ask ourselves first, what is minus k to the 1, right? Your minus k plus 1. You know that if minus k plus 1 is negative, this a will always remain like this to the exponent something that is there. You see, right? Meaning that this, when we plug 0 here, it will approach what? What will it approach? Infinite. You see, right? Or I was to say this, let me say this, it will always approach infinite. So let me say this, let me see if we can put it in another way. So if we have a and this is minus 2, you see, right? Then this would be 1 over a2, and this would be 1 over 0. Approaches infinite. We agree, right now? If k is 3, would get this. We see, right? So this would always approach infinite. So now also this one diverges. I'm glad that this one diverges also. So it also approaches infinite. So we can say now this will be this case now. We'll have equals to 1 minus infinity over minus k plus 1. So the solution would remain the same. We agree, right now? And this would be infinite. I've already shown you how did it become infinite. Then I say again, the limit x to the minus k diverges when k is greater than 1. Then I come to a conclusion now. Come to conclude. On the conclusion part, I'm going to say the improper integral diverges for k greater or equal to 1. You see that for both cases. You see right now? So we are done. This integral diverges. Any question? So I'm gonna do C now. Any question before I go to C? Okay, you can also send in the group. I think I'm watching in the group. You can also send. So we come to C. What was C saying? C was saying from 1 to infinity as k approaches 1. From 1 to infinity as k approaches 1. From 1 to infinity. Infinity. As k approaches 1. We're gonna do the same thing, right? We check if we substitute infinity there, we know it needs to be replaced. So we'll say a as a approaches infinity of 1. Okay? There's no need for me to put a sign there on infinity. You see, right? X to the minus k dx. And then we would have to go down and we see equals to the limit as a approaches infinity of x minus k plus 1 over minus k plus 1 1a. Just like that, simple. As a approaches infinity of a minus k plus 1 over minus k plus 1 minus 1. Let me just put it as minus 1 minus k plus 1. Then this would be the limit as a approaches infinity of a to the minus k plus 1 minus 1 over minus k plus 1. Then here I'm only told that k is greater than 1, right? At least I have one condition. So I'm going to say for k greater than 1. Don't forget I'm presented with k and a. So I need to check both of them. So I start with k greater than 1. What will be minus k plus 1? This one we know what will be this one when k is greater than 1. We agree right now? It will be 0. Or less than 0. If k is greater than 1. We've tested that before. And then the only difference would be how will the answer be, right? So we check now a. We say as a approaches infinity, and then a to the minus k plus 1 will approach what? So let's check. If this is negative, you know that we're always going to have this case right to the end, depending on what is the value of k. You see? So if we plug infinity here, we get that this approaches 0, so this one approaches 0. You see, right? So minus your a to the minus k plus 1 approaches 0. So this will grant us this opportunity to say 0 minus 1 over minus k plus 1 will be equals to minus 1 over 1 minus k. You see, right? Then we know now that this one converges to what? Or we simplify further, we say 1 over k minus 1. Then we can say, hence, the improper integral. So I only dealt with one case, so I can just conclude the improper integral converges for k greater than 1. You see, any question? Any question? Any question? We are fine, right? So let's come to E. Yeah?
Can you please move up?
There's what?
Slide.
I should do what?
Please move up the slide. Yeah, yeah. Just need to stay here for like 2 seconds.
Ish, this one here was supposed to be minus k plus 1. This one is minus k plus. Can I go down? I think I'm gonna be sending these things. Was it fine? But if you're copying, it's fine. Should copy fast, because as soon as cut, and I'm recording, the recording is gonna be too long. So is it fine?
Yes.
All right. So now we're going to do A, right? So A is coming from your, yes, from your tutorial. So it says the integral from 0 to pi over 2 over tan x dx. Yeah. So now we have this. All right. And then this we can check it like this. We can say over 2 sine x cos x. So what is pi? What is, I'm focused on the denominator. What is cos of 0? It's 1. So 0 doesn't give us any undefined. What is cos of pi over 2? Cos of pi over 2? 0, right? So it means that we need to replace pi over 2. So this would be the limit as a approaches pi over 2 from the negative of 0 a dx. And then this will be the limit as a approaches. So even before I do this, I can use this substitution here. Alright, I can let u be equals to cos of x, then I derive it, then I get minus sine of x dx. Then I make subject the formula dx, then I'll get this. Then I go back to substitute, right? And then to substitution, I'll get the limit as a approaches pi over 2 from the left of 0a sine x over u, or cos x in this case is u, du over minus sine x. You agree, right? Then this would be the limit as a approaches pi over 2 from the left of 0 a, this would be minus, right? So allow me to put that negative there. Minus, the sign will cancel, we have 1 over u, and then we'll have du. Then this would be minus the limit as a approaches pi over 2, the minus, then we integrate, this would get ln u of 0a, right? And then this would be minus the limit as a approaches pi over 2 from the left of ln, what was our u? Cos x, right? Then I'll plug back now. We'll have the ln of cos of A minus the ln of cos of 0. Then this will be equal to minus the ln of A approaches, the limit of A approaches pi over 2 from the left of ln of cos of A, and ln of 1 is 0, right? And then cos of 0 is 1. So this will be, if I plug inside, I'll have minus ln. Hey, why am I writing this ln like this? Ln of cos of pi over 2. What is pi over 2? Anyone can tell us what is pi over, cos pi over 2? It's what?
Pi over 2. Pi over 2 is 90 degrees.
No, cos of pi over 2. I don't want degrees here. We don't work with degrees here. Radius never gives you a degree. If you compute your answer and you get degrees,
It's a 0.
It's a 0, right? Then ln of 0 would be what? Minus infinity. So does this mean that this one diverges? Let's scan and check it. I should scan the wrong thing. I was soaked. It shocked me. Turn. Where's the turn? Turn. Push. This one doesn't have a turn. X. Cos X. Yeah, it diverges. Yeah, we are correct. We get to this. We are correct. So yeah. So is it fine? We can proceed, right? We do F. So what F says is this. F we're given the integral from 0 to 1 of the root of x over 1 minus the root of x dx. Check this. So this question, when we look at it, we'll be like, this is U substitution. So let's try it. Obviously, I would look at these two questions, right? These two functions. Remember with U substitution last time I said that first you're given two functions. The second step is that one looks scarier, the second one doesn't look scarier, right? And when you let U, you should always let U be equal to the scarier one, you see. So, and after letting U be equal to the scarier one, when you derive that U, you should be able to cancel the other function. So now let's do it and see if that theory is going to work for us. Then we're going to let U be equals to 1 minus the root of x, because this one looks like it's the scarier one, right? We derive this. When we derive x to the 1 over 2, we're going to get 1 over 2x. If we subtract 1 here, what do we get? minus 1 over 2. You agree, right? Which this would be 1 over 2 root of x, right? If you derive this over this, just gonna put it here, right? So this would be, so that one would be multiplied by this negative. So we're going to have minus 1 over 2 root of x instead of the positive one, right? Dx. Then we need to make a dx of the formula. We're going to have this, which is dx, right? And then we come and say, we have the root of x over 1 minus u. That one is u. We have minus 2 root of x. Don't forget, we said what? We said that after deriving this, you should find that whatever you get should be able to cancel this limit. Can we be able to cancel this limit like that? Can we cancel it?
Yes.
How can we cancel it? How can we cancel this then? How can we cancel it? Are they not going to multiply? They are going to multiply, right? We agree, no?
Yeah.
So they are going to multiply. So if they multiply, what are we supposed to do?
Can't we take the 2 and take it outside?
Okay, let's do that. Let's check what you're saying. Minus 2, 0, 1. The x root will multiply with the x root, will have x over u du. How will you get rid of the x? It will be a problem, right? Wait, did I apply those? Oh, I did here. Yeah, it will be a problem, right? You see right now? We agree, ne? So the easier way around this, right? We come to, don't forget, U substitution have standards. This is standard 1, so we can come to standard 2 of U substitution. Standard 2 of U substitution says we can let this root be something else. Let's say let it be, we're used to using a here, right? Maybe I'll use what m. Then I derive this. When I derive the root of x, we know what we get, right? 1 over 2 root of x dx. We agree, ne? Then we'll get 2 root of this dm is equals to dx. Then here would come back, right? Don't forget here I'm just showing you substitution. I'm not yet solving. So this would be m. This would be m 1 minus m. And then would have this. Here would have dx is 2 root of x dm. Then this would be 0, 1. So what is this one? Would get m times 2. What is root of x? Is m, right? So the m would times by the m will get m squared minus 1 over m dm. Do you agree here? This is the second standard of U substitution. Usually the majority don't know this use second standard, but yeah, it's when you get deep to understanding U substitution, you realize that you can get to this part of U substitution. So Don't forget I substituted m here. This is equals to m. Don't forget this is equals to m. So m times m will give us m squared, which is this one, times 2. The 2 will remain. Is it understandable, guys? So you understand it. Then this second standard will require you to come and use long division. So I remember I said that I showed you this last time, long division, on how to do long division. I was like, it's very important. This guy, he won't give you simple questions. It doesn't work like that. It doesn't bring simple questions. It doesn't just bring simple questions. It doesn't work like that, man. So I want m. I'm interested in m. So if I take m squared, you divide by minus m, I get minus what? M. You agree, right now? Then I took this, divide by this. Then now I multiply it back with these ones, right? It means that I'm going to get m minus m times minus m is m squared. Minus m times 1 is minus m. So this m squared minus m squared will give us 0. Then 0 minus m will be plus m. So this m and m, they can still work out, right? I take m, divide by minus m, I get what? Minus 1. Then I take minus 1 and multiply back. I'll get m and minus 1. So m minus m is 0. Minus 1 will be plus 1. So 1 can't divide with m anymore. So I need to come and write here plus 1 over 1 minus m. You see, right? Then this is my interested part, which I can take and put inside there. So this will be the integral. It was what? There was 1, right? So we know that that one is the same as minus m minus 1 plus 1 over 1 minus m dm, right? That is the same thing, right? Then here can have the limit as a approaches. If we apply here, so here I'm just showing you, right? So you're gonna go back and apply it from here. You start by the limit. After having the limit, this will be your second step. You see? So I'm just doing that there so that you can see. So it means that, okay, let me just maybe take it from the first, since already we know what this would be, right? So I'll stop here. Then I say that I'll write here so that I don't get confused. That's fine. Let me just take it from there. Since there we have the integral of 0 to 1 root of x over 1 minus root of x dx. This would be the limit. As since I plug 1 there, it's gonna give me a problem, right? A approaches 1 of the integral of 0 to a, and this one is from the negative, for root of x over 1 minus root of x dx. And we know what this is equals to, right? I did it there. This is equals to the limit as a approaches 1 from the negative over 0 a is minus m minus 1 plus 1 over 1 minus m dm, right? And this will be the limit as a approaches 1 from the left. If I integrate this, I'll have minus m squared over 2 minus m plus, this one also requires its own u substitution. Do you agree with me? So it means that that one will be, instead of plus, it will be minus the ln of 1 minus m. So I say 0 a. So this would be the limit. This would be too long, guys. Do you agree with me that it's gonna be too long if I plug these things, right? Let me just do them individually. We'll do them individually. Let me do this. I'm gonna write them to be too small, which is 1 from the left of. If I substitute on this one, a, it will be minus a squared over 2. I won't substitute 0 there because it will give me 0. It will be minus a. I won't substitute 0 also because it will give me 0 minus the ln of 1 minus a plus the ln of 1. Also this one is 0, yeah. So it's not that long as I thought it will be. The limit is a approaches 1 minus, and then we have minus a squared over 2 minus a minus ln of 1 minus a. Then this will be the limit as a approaches minus, not 1 minus, let me just plug from here. So this will be minus 1 over 2 then of 1 minus 1. Do you agree with 1 minus 1? Do you agree with room 1 minus 1? Oh, yes. I forgot this. I'm supposed to substitute back my m, our m, before I substitute these values. Yeah, I'm supposed to substitute because we didn't change the intervals, right? We're using this one of not changing the intervals. I didn't substitute back my m. Our m is the root of x. I forgot to take it back. If you don't substitute, we'll get wrong answers. Then this will be minus root of x squared over 2 minus root of x minus ln of 1 minus root of x 0a. Yeah, ish. Don't forget this, guys. If you didn't change the intervals, don't forget to plug back. So now I can plug now. I'll have this will also be like minus x, right? So this would be minus a over 2 minus root of a minus the ln of 1 minus root of a. And then this other one is what is, this was the reason I'm not plugging 0. It would give me 0, right? And then this one would be plus the ln of 1 minus root of 0. Then this would be to be minus, if I substitute the limit, I just left out the limit because of space, right? If I substitute the limit, I have minus 2, and then this would be minus 2 m squared 2. Let me see, m squared 2. Where's the 2? I think this one had 2 outside, ne? Oh yeah, there was 2 here. I forgot this 2. Yeah, don't forget these things, guys. I just forgot them because I had a lot of things here. There was 2 here. 2. 2. 2. Yeah. Minus 1. As ln of. This is 1 minus. It's 1 minus what? This is the limit of a, right? Let's see, the limit of a. Okay, let me erase this and write it. I think I lost it from where we have 2 there, because I don't know what I did here. Because if I continue from here, I might make mistakes. So let me just start it from here and take it from where we have it there. This was the limit as a approaches 1 from the left, 0a. This way 2m squared over 1 minus m dm. I think it's like this. Let me check. Yeah, it was like that. So I can take out the 2. Can take out the 2. The limit as a approaches 1 from the left over 0 a m squared over 1 minus m dm. We agree with this right now. And then this will be 2, the limit as A approaches 1 from the left of 0, A. Then that limit was minus m minus 1 plus, yeah, minus m minus 1 plus 1 over 1 minus m into m. So let me just put this together so that I don't make mistakes. I'll just do them like this. If I integrate minus m, I'll get what? Minus m squared over 2, right? If I integrate minus 1, I'll get minus m. If I integrate 1 over 1 minus m, I'll get minus ln. Because if I derive my proper derivative of the inside is minus, right? That's why I have minus ln. Minus ln 1 minus m. Alright. And then I think this would be the case. And then this would be 0 till a. And then when we plug this, we're going to have, so this is minus, which is 1 from the minus. And then this would be minus. We know that this m is the same as root of x, right? Squared over 2 minus root of x minus ln minus root of x 0a. I just plug back my root of x so that I can plug those 0a to the limit. Yeah, and the person who's making noise here was supposed to be attending here. I don't know what they're doing if they're not attending. So this would be minus x. It would be minus x over minus x over 2, and then minus root of x is ln of minus 1 over x 0a. Yeah, so now I can substitute because I've simplified it. Then this will be 2, the limit as a approaches 1 from the left of minus a over 2. Because if I substitute 0, we know that it will give me 0, right? Minus a, so ln of minus 1 a. Because even if I substitute 0 here, I'll get ln 1. Ln 1 is 0, we know. Then this will be 2. Then I apply the limit. I have minus 1, 2, minus 1, minus the limit of 1 minus 1. Right? Then this would be 2 minus 3 over 2 minus ln of 0, and this would be minus 3 minus 2 ln of 0. And ln of 0 is what? What is ln of 0, guys? It's
Negative infinity.
Negative infinity, right? So this would be, now we'll get, if we plug 0, 1, okay, it's fine. We get minus infinity overall. So this thing diverges, you see, right? So we got that it diverges. So let me try to scan and see what we get. Yeah, diverges. Let me send a screenshot so you can see. So this one diverges. Now let's go back to those nodes. Let's go back to these nodes. Yeah, it's unfortunate we're still on page 1 and we have 4 pages. So let's do the comparison test, right? Then we complete some questions based on comparison test. So let me stop this recording, then I'll record again now, and then I'll call the next one comparison test. So they don't have to be too long.